everybody, this is Module 4 for Math 026 for Hartford Community College. And in this module, we're going to look at functions. We're going to look at the definition, the domain, the range, graphs, operations, and then inverses as well. And this is part 1. We're going to start off and look at some terminology associated with functions. And our first one is a relation is any set of ordered pairs. So if you have a set of ordered pairs, it is called a relation. The domain of the relation is the set of all the first components of the ordered pairs. So when we think of domain, our ordered pairs typically are made up, the first one is that x value. So think x values are your domain. The range of the relation is the set of all the second components of the ordered pairs. So again, think of the y values here. And a function is a specific relation in which each of the first components correspond to exactly one second component. So not all relations are functions. And we're going to take a look and define functions by looking at relations, different relations. So here, for example, A, we have a set of 4 ordered pairs that are made up, they make up a relation, and they want us to list the domain. So it's always the first of the ordered pairs, the first value in the ordered pair, so our x values here. So our domain for this function is 0, 4, and again, I am just looking for that first value. Then we have 3 and 10. Now my range are the second values in the relation. So it's going to be 2, 5, 7, and -1. Now, this is asking, is this relation a function? So a function is defined at or as a relation in which each first component corresponds to exactly one second component. So if I take a look here and I draw some lines, 0 corresponds to 2, 4 corresponds to 5, 3 corresponds to 7, and 10 corresponds to -1. Because each of my x values has exactly one y value, this is a function. So yes, this is a function. So we're going to continue here naming our domain and range and seeing if it is a function or not. So for B, we have our domain would be all our x values. So it's going to be -3, 0, 5, and 1. And then my range is going to be 2, -2, 5, and then we have another 5 that repeats, but I'm not going to write that second 5 because I don't need to. If it repeats, you just write it once. Now we're going to see if this is a function. So each x value has to have exactly one y value. So if I look here, I know that -3 goes to 2, 0 goes to -2, 5 goes to 5, and 1 goes to 5. Now, you may be looking at this and saying, well, I don't think this is a function because we have 2 numbers going to that 5 in the range. But the definition of a function says that each x value has exactly one y value. Each of my x values only go to one y value or one range value. Now, it just so happens that 5 and 1 go to the same range value, but that is okay. I tend to think of it this way. Think of your domain, think of that as people, and your range as rooms. Okay, I can send more than one person to a room, but I can't have a person go to 2 different rooms at the same time. We're not Harry Potter. We can't travel back in time and do that. So it's okay for the domain, as long as each value of the domain has one y value, it is a function. Doesn't matter if two numbers of the domain have the same y value, that's okay. So yes, this is a function. Let's look at C. My domain here is going to be -3, 0, and then 5. And 5 is repeated twice, so I'm only going to write it once. And then my range is going to be 2, -2, and 6. And that -2 again is repeated, so I'm not going to write it twice. Now let's look at our relationships. -3 goes to 2. 0 goes to 2. 5 goes to 6. And then 5 also goes to -2. Oops, I drew the wrong line. Let me erase that. 5 is going to go to -2. So let me put my 5 there. Goes to 6. And it goes to -2. And 0 goes to -2. Okay. Now, notice here that 3 and 0 in my domain have their own y values, but 5 goes to -2 and to 6. So that means that if this is a person, 5 is a person, it's got to be in two places at once. Can we be in two places at once? The answer is no. And because 5 goes to two different range values, this is not a function. So no, it is not a function. All right, if we look at D, the first part of the function we're going to call our number grid, because that's the first part we see. That's going to be our domain. So we have 95, 81, and 73. And then we have our range, which is our letter grades. We have an A, a B minus, and a C. Now, they actually have drawn the relationships here. So you can see A goes to 90, or 95 goes to A, but 81 goes to B and to B minus. So B, that 81 goes to two different places at once. So is this a function? Because 81 goes to two different range values, that would be a no. It is not a function. So because every set of ordered pairs is a relation, but not every relation is a function, we have what we call function notation to show that a statement or an equation or an expression, is a function. So when you see y equals, if it is a function, you can substitute that y equals with f of x. So functions will always start off with f of x, and it stands for f evaluated at x, or f of x. It is the function at x. So f of x equals x squared minus 3 is the same as y equals x squared minus 3. But again, that f of x tells us that yes, this is a function. It passes what we call the vertical line test, which we're going to take a look at in a few slides, to be a function. Now, the first thing we're going to do is just evaluate functions. So our function that we are given is f of x equals 3x minus 4. And they want us to find f of 2 and f of -3. So what this means is, since our function is evaluated at x, and f is now 2, or that number in the parentheses is 2, we're going to plug in the 2 wherever there is an x. So f of 2, if we are evaluating it, means we're going to do 3 times 2 minus 4. And that will give me 6 minus 4, which equals 2. So again, you just plug that value in and do the math. Now, we are going to do f of -3. So f of -3 will mean we're going to do 3 times -3 minus 4. So that will give me -9, because 3 times -3 is -9, minus 4. Again, addition of the opposite. It is going to equal a -13. So f of negative 3 in this expression is equal to negative 13. So we're going to continue to evaluate here. And now we're going to take a look at g of x is equal to negative 7x squared plus x. That's our function. They want us to find g of 3 and g of negative 4. So g of 3 will be equal to negative 7 times 3 squared plus 3. I know that order of operations says I have to do my exponent first. So 3 squared is 9, and we'll do 9 times negative 7 plus 3. Negative 7 times 9 will give me negative 63 plus 3. Negative 63 plus 3, will equal negative 60. Now for g of negative 4, I'll plug in negative 4 where x is, so we'll do negative 7 times negative 4 squared plus a negative 4, or you could just write minus 4. Again, do the exponents first. So negative 4 squared is 16. And now we're going to do negative 7 times 16. And that is going to give me a negative 112 plus a negative 4. So my final answer here will end up being negative 116. For C, first thing we're going to evaluate is P of A. So we are going to, for this one, just do P of A will be 4a squared plus 2. And the nice thing here is I can't do any more simplifying, so that's it. It's done. Now the other one, P of B plus 1. We can do some work there. So P of B plus 1. When we plug it into our original equation, we're going to have 4 times B plus 1 squared plus 2. Now I can square B plus 1. So we're going to need to FOIL here. So we're going to have 4 times B plus 1 times B plus 1 plus 2. So I'm going to start by distributing that 4 first. So it will give me 4b plus 4. And then times, I still have that 4b plus 4 times the b plus 1 to do. So now I'm going to FOIL. And I'm going to end up with 4b times b is 4b squared. 4b times 1 will be 4b. 4b times, or 4 times b will be 4b. And then 1 times 4 will give me another 4. And then we're going to simplify this. So it's going to end up being 4b squared plus, I can add these two middle terms, 8b plus 4 plus 2 is 6. So my final answer there is 4b squared plus 8b plus 6. So earlier I mentioned, we use function notation to show that an equation or an expression is a function. And we know that because it has passed that vertical line test. So now we're going to look at the vertical line test. The graph of a relation passes the vertical line test if it is a function. So if it passes the vertical line test, it's a function. And in order to pass the vertical line test, no vertical line can be constructed so that it intersects with the graph at more than one point. So here, for A, we have a straight line. And basically, I want you to imagine I'm taking my pencil and I'm laying it down on the graph. So it's going straight up and down, even though my line is not perfect. As I move this pencil across the graph, okay, and remember, it's going to remain vertical. So I'm going to move it across the graph from left to right, like we read. That vertical line can always only touch one part of my graph. So when you have a line is always, as long as it is not a vertical line, going to pass that vertical line test. So for A, yes, it passes the vertical line test. It is a function. Now B, if I draw a vertical line in here, I want you to notice that vertical line right now hits the graph here and it hits the graph here. It hits the graph at more than one place as I do the vertical line test. So B, right off the bat, I can tell is not a function because it does not pass the vertical line test. So this one is not a function. C, hopefully you're looking at that and you're like, well, that's definitely not going to pass the vertical line test. Because again, if I draw my line there, it's going to hit here and here. So again, not a function. Doesn't pass that vertical line test. Now for D, this one is a little bit harder, but when I look at those lines, if I draw them in, because you can't see my pencil moving along, but notice all those vertical lines that I'm drawing hit the graph at exactly one spot. So D is yes, it is a function because it passes that vertical line test. So here we're going to talk about looking at a graph and listing that domain and range, and they want it in interval notation. So interval notation, remember, is when we use like the parentheses. Move that back for you. The parentheses or the brackets. The parentheses would be if it doesn't, it goes right up to the number but doesn't include it. The brackets mean it includes the number. So remember, your domain is your x values. So if I look at this graph here, I need to find where this graph intercepts with that x-axis. And so from these 2 points, so we have a circle there, in that middle, those, anywhere where I drew that blue line, I have an x value that has a y value. So, you know, if my x value is 1 right here, I know that y will be something up here or something down here. So my domain for this one looks like it goes, it's touching, so it goes from -2 to +2. And because it includes -2 to +2, I'm going to put the brackets around it, not the parentheses. Now, if we look at the y values, it looks like, so here's my y-axis, the graph is covering those points, that my range goes from -3 to +3. And it does include those. It looks like it stops there. And again, this is kind of an estimation because we're looking at the graph, but that looks to be my range. Okay. So now, if you look at B, my domain, again, you're looking for the values that it meets on the x-axis. And here, anywhere between -3 and 3, if I pick a value between those points on the x-axis, I can find a y value. Now my range, we want to look at basically how high and how low does this graph go. So here's kind of like a minimum, and here's a maximum on that graph. It looks like it goes from -1 to +1. And I know the negatives didn't come out very well on here, but just think when they're below or beyond, those are our negatives. All right, so for C, if you look at this is an absolute value graph, but notice that we have on the end of this line, we have those arrows, which means it goes on forever and ever. Because it goes on forever and ever, this means that it's going to keep stretching out. So my domain, it's never going to end. My domain is going to end up being -infinity to +infinity. It's never going to end. And when you have infinity, you always put parentheses around it because it's not an actual value. It's, infinity is not a number. It never ends. Now my range, if I look at that y-axis, I don't have any values down here on the bottom. My y-axis starts right here at 0. And then because it's going on and on and on and it keeps going up, it's going to go on to +infinity there. And again, infinity, you always put parentheses, but numbers, if it goes to that number, you put a bracket. Okay, so now For D, again, I have those arrows, so it's going to keep expanding out, which means my domain here, again, is going to be not a bracket. It's going to be from negative infinity to positive infinity, because it's going to keep going on forever. But my range, I have values covered down here, and it's going to go on negative infinity. This is going to keep going down. But it looks like it starts right here at 2, and then up here, I don't have any part of that graph. So it's going to go to 2 and stop there. Now, domain and range, looking at a graph, it's a little hard when they go on infinitely. You have to be able to visualize it. So it is something that takes practice. So the more you practice, the better you'll get. Okay, so here we have 2 more. We want to find the domain and the range for. Now, when we have a line that extends on infinitely on both directions, the domain and the range for a line is always going to be negative infinity to positive infinity. The domain will be that, and also the range, because it stretches up and down infinitely, and that's an 8, not an infinity. Let me get that better. All right, negative infinity to positive infinity. And now for F, my domain, even though this has a little curve to it, it's going down and out and up and out. So my domain again would be negative infinity to positive infinity. And the range, because again, it's got that spread, it's going down, so it's going to cover that bottom part of the axis, and it's going up, it'll cover the top part. It will also be negative infinity to positive infinity. So here, the domain of functions. The domain of a function is the set of all values for which the function is defined. We're basically saying here, if we talk about the domain as our x values, what values for x can we plug into the problem where it will give us an expression that is defined? For instance, when we're looking for a domain, we're typically looking at if we have a function that is a fraction. Because remember, with a fraction, you can't have 0 in your denominator. So if you get a 0, if you plug in a value for x and it results in a 0 in the expression, then that expression is undefined, or that fraction is undefined. And then also, if we have an even-powered radical, like a square root or a fourth root, we can't have a negative value when we're dealing with those real numbers. So that's what we're going to look at when we ask, or we're looking for the domain of a function. So we're going to look for any fractions. And if we have a fraction, any values that would make the denominator equal to 0. And then if we have a radical, an even-powered radical, though, values that produce a negative number under that radical. So for A, we have a fraction there. And then it is, we're only focusing on the denominator. I don't care about the numerator. But my denominator is x minus 2. So I need to find out when the domain is undefined. So what I'm going to do is just take that expression x minus 2 and set it equal to 0. So I'm going to solve that equation by adding 2 to both sides, and x equals 2. So if I plug in a 2 into this expression, I will get a 0 in my denominator. So that means for this one, my domain is all real numbers. So my domain for A would be all real numbers except x cannot equal 2, because if I plug a 2 in there, that's when I'll get a 0 in my denominator. If we look at B, again, I don't really care about the numerator. It doesn't matter if there's an x up there. It's only that denominator that I'm concerned with. So I have my 16x plus 5, and I'm going to set that equal to 0. Solve the equation by subtracting 5 from both sides. We get 16x equals negative 5. Divide by 16. So x, in order, when we get a 0 in the denominator, x would equal negative 5/16. So again, our domain here is all real numbers except when, or except when x is equal to negative 5/16. So except when, or you could say except x cannot equal, so we could change this instead of except when. We can say all real numbers except x can't equal negative 5/16. Now, if we look at G, we have the square root of 3x minus 2. And again, we don't have to worry about it being 0, but we have to worry about that value underneath when we substitute in a number for x, giving us a negative number. So what we do when we have a radical is you're going to take your value under the radical, so my 3x minus 2, and we're going to turn it into an inequality. Whenever we solve this equation, the value for x must be greater than or equal to 0. So now what we're going to do is solve this by, adding 2 to both sides. So now I have 3x is greater than or equal to 2. Divide by 3. So x is going to be all real numbers that are greater than or equal to, and I know this is kind of crazy, 2/3. That 3 didn't really turn out there, did it? But x, in this case, the domain is any number that's greater than or equal to 2/3. This is my domain for that equation. Now we'll do the same thing with D. We will take what's under the radical, so 10 minus 19x, and it has to be greater than or equal to 0. So I'm going to start off, I'll subtract 10 from both sides. So we get negative 19x is greater than or equal to negative 10. Now I am dividing here by a negative 19. Remember, when you divide by a negative and you have an inequality, you have to flip that sign. So now I'm going to have to rewrite it. It's going to be x is less than or equal to 10/19. And the 10/19 came from the 2 negatives, make that a positive. So now I have x is less than or equal to 10/19. And that would be the domain for that function. All right, next we're going to take a look at E. And this one's kind of like a double whammy because we have a fraction and a radical in that denominator. So here, because it's a radical, we have to turn it into an inequality. So we're going to have 7x plus 4. But now, x has to be greater than or equal to 0 for a radical. But we can't have 0 in our denominator. So now instead of greater than or equal to, we're just going to have 7x plus 4 is greater than 0. Because we need a number larger than 0 here. And I'll go ahead and solve my radical. Or not my radical, my inequality. And it's going to give me 7x is greater than negative 4. I'll divide by 7. So x is greater than negative 4/7. And that would be my domain. Now for F, if we look at this, it is a quadratic equation. But I don't have a fraction to worry about. I don't have an x in a denominator. And I don't have a radical. So for this one, my domain, because I don't have to worry about that fraction or the radical, my domain is going to be all real numbers. There's nothing else we need to do here. We don't have a fraction or a radical, so it's all real numbers. So now we are going to look at graphs of functions. And a function can be graphed either using a table of values or a calculator. We are going to graph these by hand just to practice it. But again, once you get comfortable with that calculator and you kind of know what the graph is looking like and what you're looking for, you can use your calculator. Don't forget f of x means y. So really we have over here for this one, y equals 2x plus 1. And they give us a table of x values. So we got to find the y values or f of x. So my first value is a negative 2. So I'm going to do 2 times negative 2 plus 1. And when I do the math there, 2 times negative 2 is negative 4. Negative 4 plus a positive 1 will give me a negative 3. So my f of x or my y value is negative 3 for that one. Now if I plug in a -1, we'll have 2 times -1 plus 1. 2 times -1 gives me a -2 plus 1. So it's going to equal -1. 0 is the next number I'm going to plug in. So 2 times 0 plus 1 is going to equal 1 because 0 is 0. 2 times 1 plus 1. 2 times 1 is 2 plus 1 will give me a +3. And then 2 times 2 plus 1 will give me, 2 times 2 is 4 plus 1, so it gives me a 5. So now we're going to go ahead and plot those points. So I have -2, -3. So remember, find the x value first, then go down to your y. So -2, -3 is going to be right here. -1 is right here. 0, 1 is right there. 1, 3 is right there. And then 2, 5. So now we are going to draw our line. And there's the graph of our function. Okay, so next we have x squared minus 3 is our function that we're graphing. So I'm going to plug in the values they give us for x. So we'll start off, we are going to do first -2 squared minus 3. So -2 squared is 4. 4 minus 3 will give me a 1 for g of x or y. Next, I have -1 squared minus 3. So that -1 squared is 1. 1 minus 3 will give me a -2. 0 squared minus 3. 0 squared is 0. 0 minus 3 is -3. 1 squared minus 3. 1 minus 3 is going to give me another -2. And then 2 squared minus 3 is going to give me, 2 squared is 4. 4 minus 3 is 1. So now when I go to graph these, I have -2, 1. I have -1, -2. I have 0, -3. I have 1, -2, and 2, 1. And this we know is an x squared, so it's going to form that parabola. And again, my stylus doesn't draw beautifully, but there we go. It's kind of parabola shaped there. It's not perfect, but there's our parabola. So here we have a radical x minus 1. So we are going to go ahead, and they gave us some x values here. We're going to start off with the square root of 1 minus 1, which will give me the square root of 0, which we know equals 0. Next, we have the square root of 2 minus 1, which is going to give me the square root of 1, which equals 1. Then we're going to do 5 minus 1, so it's going to give me the square root of 4, which is going to equal a whole number 2. And next we have 10 minus 1, which gives me the square root of 9, which equals that whole number 3. So we're going to go ahead and graph these. We have 1, 0. So that'll be right here on the x-axis. 2, 1 will be right here. 5, 2 is going to be here. And 10, 3 will be right here. So here is our graph right now. So next, we are looking at the absolute value. J of x is equal to the absolute value plus 3. So when I go to substitute my values in, we have the absolute value. Fix that. All right, the absolute value of -2 plus 3. Remember, the absolute value is the distance a number is from 0. So the absolute value of -2 is 2. It's 2 spaces away from 0. So we have 2 plus 3, and that's going to give me 5 for J of x. Next, the absolute value of -1 plus 3 is going to be, the absolute value of negative 1 is 1. 1 plus 3 is going to give me 4. The absolute value of 0 is 0. So 0 plus 3 is 3. Then the absolute value of 1 plus 3 is going to be, the absolute value of 1 is 1. So 1 plus 3 is going to equal 4. And then for 2, the absolute value of 2 is 2. 2 plus 3 is going to be equal to 5. So now I'm going to go ahead and plot my points. I have negative 2, 5. I have negative 1, 4. I have 0, 3, 1, 4, and 2, 5. So I can draw that. And there's my graph, my absolute value graph. So now we are going to give a rough sketch of the graph of each function using a graphing device. So we're going to break out those graphing calculators, and I'm going to sketch the graphs on here. Again, use your graphing calculator just like we did in our last section when we were graphing quadratics. So to graph, we are going to start off with our y equals button. We'll hit that y equals, and I'm going to type in negative x squared plus x. And when I do that, using my standard window, which is just from, for the x values negative 10 to 10 and y values negative 10 to 10 again, my graph looks similar to this. And again, it's a rough sketch. It is not always going to be perfect. So, accept the rough sketch of it, the rough nature of it. I'm going to try to do that so it'll be a little bit thicker line. I know it's not perfect, but it's going to look somewhat similar to that. And that would be the rough sketch of our graph. I will try to post a video of me doing the graphing calculator so you can kind of see how to put them into the graphing calculator. Again, we're using the standard window. So if you need to get to that standard window, if you're not sure you have it, I'm using the Texas Instruments graphing calculator, you can go to Zoom, which is in that top row of buttons, and do Zoom number 6, and that will always put you to the standard window. Now let's graph our x cubed plus 1. So I'm going to put in my x value, do the little caret so I can get the exponent, and then plus 1, and we'll graph it. All right, now our graph for this one, and again, trying to make it a little bit easy to see. It's, let me try. I am not perfect at this. It goes through here, and then goes through there, and up. Actually, it should be up a little bit higher. It should go right up through there. And not quite like that. It keeps going up this way. Let me fix that for you guys. I am not fabulous at drawing, as you guys can see. All right, somewhat like that. All right, but that's a rough sketch of that graph. And now we are going to graph 1 divided by x. So I put that into my y equals, and that graph is going to look like it's going to ride right along that x-axis. It's not going to touch it, but it's going to look like it is, and then go down right along that y-axis. Again, it's going to get very close to it, but not touch it. Same thing on the other side. Again, it's going to get very close, and I can't get too close, but it'll ride right on it. So it looks similar to that. And then our last one that we're going to do is the square root of 5 minus x. And when I graph that one, it is going to look like, it's going to cross over there, and it's going to go all the way down to 5. So it looks something like this. It goes up like this. There we go. All right, so that is our graph there. And again, we're just using a graphing calculator to roughly sketch them. So you go to your y equals, enter the equation in. If your window is not the standard window or doesn't look similar to the graphs I have on here, you can do zoom number 6, and that will give you the standard window on the TI-84, 83 graphing calculators. The next thing we're going to look at in this section is operations on functions, and this is the last thing we'll do for part 1, and then we'll look at some other stuff in part 2. But with functions, you can add, subtract, multiply, and divide functions. So you can kind of see they have given us here just some directions. If you have f plus g of x, it means you add the two functions together. F minus g of x means you would subtract the two functions. So it's really like working with polynomials. Multiplying two functions, you multiply the two functions together. And then division, the only caveat you need here is g cannot equal 0. So we can't have 0 in that denominator. And we're going to practice some of these. So first we have f of x equals 3x minus 1, and g of x equals 5x plus 6. They want us to find f plus g of x and f times g of x. So let's start with f plus g of x. So that means that we are going to add together 3x minus 1 plus 5x plus 6. And when we do that, we'll combine our like terms here. So 3x plus 5x will give me 8x. Negative 1 plus positive 6 will give me a positive 5. So my answer here is 8x plus 5. And then now we're going to multiply the two expressions together. So f times g of x is the same as doing 3x minus 1 times 5x plus 6. And now what we're going to do is we're going to multiply. So 3x times 5x will give me 15x squared. 3x times 6 will give me plus 18x. And then negative 1 times 5x will be negative 5x. And negative 1 times 6 will be a negative 6. So that is going to give me, for my final answer, 15x squared plus 18x minus 5x will give me positive 13x minus 6. And that would be our final answer. We can't do any more because there aren't any like terms to combine. Okay, so here we are going to do, for B, we have f of x equals 2x squared minus x plus 4. G of x equals x squared plus 2x. First, we're going to do g minus f of x. Because g comes first, we are going to list that function first. So it is going to be x squared plus 2x minus, and then we are going to put in parentheses because it's minus that whole function, 2x squared minus x plus 4. And here, reminder, when you're working with these, you need to distribute that negative that's outside the parentheses, that negative 1. So when I do that, I'm going to end up with x squared plus 2x, and then it's going to be minus 2x squared plus x, because negative 1 times negative x gives me a positive x, and then negative 1 times positive 4 will give me a negative 4. We will combine like terms here, so negative 2x squared plus positive x squared is going to give me negative x squared. 2x plus x will give me a positive 3x, and then minus 4. So negative x squared plus 3x minus 4. Now for the second one, they want f divided by g of x. So that will be, if we put f on top, 2x squared minus x plus 4 over x squared plus 2x. Now, you do want to look at this to see if we can do any simplification. But I believe if I look at the top, it is not factorable on the top. So even though we could factor the bottom, we can't do any simplification. So this would be all we could do here. If we could simplify, we would cancel out common factors on the numerator and the denominator, but we don't have anything that we can do. So that would be it for that one. All right, so finally we have f of x is equal to 1 over x, and g of x is equal to 1 over x squared. So we want to find f plus g of 3. So what we are going to do, what I tend to do with these, and you can do them different ways, but I start off and I do f plus g of x, which is really going to give me 1 over x plus 1 over x squared. Now, they want us to substitute in a 3, so we're going to do f plus g of 3. So that's going to give me 1 over 3 plus 1 over 3 squared, which is the same as 1/3 plus 1/9. Now, I do need to add these together, but to do so, I need to find a common denominator, and I can use 9. So my first fraction, I'll make it an equivalent fraction with a denominator of 9. Multiply the top and the bottom by 3, so I end up with 3/9 plus 1/9. And when you add that together, you end up with 4/9. And that will be your final answer. Next, we are going to do g divided by f of 4. So g divided by f of x is the same as 1 over x squared divided by 1 over x. Now, if I do g divided by f of 4, that will give me 1 over 4 squared divided by 1 over 4. So now we can take that as a complex fraction, but it's a division problem. So we have 1/16, because 4 squared is 16, divided by 1/4. And that is going to give me, we'll make it addition or multiplication of the reciprocal. So we'll do 1/16 times 4 over 1. And when I multiply, I end up with 4 over 16, which would simplify to 1/4. And that would be my final answer for that one. And that is the final answer for this part of the module, and we will stay tuned for part 2.